Okay, this is problem 334. Has to do with throwing darts. In the game of darts, the player stands with feet behind a line 2.36 meters from a dartboard, with a bullseye at eye level. Suppose you lean across the line and release a dart at eye level, 1.8 meters from the board, and hit the bullseye. Find the initial velocity of the dart if the max height of its trajectory is 1 centimeter above eye level. Okay, so one thing to note right away, velocity means speed and angle, and that's the way we're going to answer the question here. So first thing I want to do is to draw a picture of what's going on here. And let me draw an axis, y-axis in meters, and then a distance axis here. This is going to be the x-axis. And let's say that the dart is released at eye level. So let's say this is eye level right here at horizontal. That's supposed to be an eye right there. And the bullseye is right over here. And the dart then does something like this. Like that. And this distance right here, this height right here, is 1 centimeter. 0.01 meters, in other words. And what we're trying to do is we're trying to find the V here and the theta that will do that, where we're also given this distance, 1.80 meters. Okay, a couple of preliminary things. First of all, I'd like to derive a range equation, and basically the way I'm going to do that is to understand that the kinematic equation for the y direction is going to be Vy equals Vy0 minus gt. Now I know that the beginning y velocity is going to be the negative of the ending y velocity. So I can use that fact to put minus Vy0 on the left side equals Vy0 minus gt. Okay, in other words, what I'm saying is that if I have a Vy0 here, when it gets over to the dartboard, it's going to be equal and opposite Vy0 pointing down. There's a negative right there. Okay, so I can solve this for t, and the result of solving this for t gives t equals 2 Vy0 over g. This is going to be the flight time for the arrow, for the dart. Alright, the other thing I know is what x is. That's the range. And x is going to be equal to v x naught times this t, the same time of flight that I have here. And so if this is Vy naught, the Vx naught corresponding to it would be something like this. That's not going to change. There's no acceleration in the horizontal direction. So I can then plug in the t that I have up here and conclude that x is equal to 2 Vx naught Vy naught over g. That's the range. That's how far the dart goes, according to what my Vx naught and Vy naught are. Okay, so the next thing to get our hands around is what Vy naught is. And in order to do that, I'm going to use the kinematic equation that doesn't have time in it. Vy squared is equal to Vy naught squared minus 2gh. Okay, so the h is, in this problem, corresponds to 0.01 meters 1 centimeter. And I can solve for Vy naught. At this particular point, Vy is going to be 0. And so that gives me Vy naught is equal to the square root of 2 times g times h. Let me write that again here. Two times g times h. Okay, so that's going to be equal to 2 times 9.8 meters per second squared times 0.01 meter, which gives 0.443 meters per second. That's the initial upward y velocity that will work. And now I can use the range equation that I derived above here, this guy right here, to solve for Vx naught. And so I can take this, x equals to 2 Vx naught Vy naught over g. I know what x is, it's 1.8 meters. I know what Vy naught is, I just solved for it. And Vx naught is equal to x times g over 2 times Vy naught, which is equal to 1.80 meters times acceleration of gravity divided by 2 times the Vy naught that I found above, 0.443 meters per second. And that is 19.92 meters per second. That dart is being thrown pretty fast. It's got a pretty shallow profile here, so that would have to be the case. Alright, so I know Vx naught and I know Vy naught, so I can figure out what V is with the Pythagorean theorem. V is equal to the square of Vx naught, 19.92 meters per second, squared, plus Vy naught, 0.443 meters per second, squared. The square root of that is equal to 19.93 meters per second. And the angle, let me draw a little picture up here. So basically what we have is we have our Vx naught here, and we have our Vy naught here. Here's V. This is the angle that I want. Theta. The tangent of theta is equal to the ratio of Vy naught over Vx naught, so clearly the angle is equal to the inverse tangent. So theta is equal to the inverse tangent of 0.443 over 19.92. Punch that in on the calculator. 1.3 degrees. So to summarize, we have to make the dart go 1.8 meters and to hit the bullseye and to achieve an apex 1 centimeter above the level at which it was thrown. The dart has to be thrown at 19.93 meters per second at an angle of 1.3 degrees elevated with respect to the horizontal.